And now we're going to get to the real heart of this lesson. We are going to plan a coordinate proof. What is a coordinate proof, you ask? That's simple. That's a proof using the coordinates on a coordinate plane. Here is a parallelogram. I have named it KLMN. K is the origin, and I've just used the coordinates that we found from our previous problem. So let's say that we're given that KLMN is a parallelogram. Let's prove that the diagonals, segment KM and segment LN, bisect each other. So first, we place the figure on the coordinate plane using the rules. We've already done that, but I suppose we should double check to make sure the coordinates work using the distance and slope formulae. In this case, we just need to use the slope formulae on the top and bottom lines. Notice the top line. Let's look at the slope there. Since our y coordinates are the same, the numerator becomes 0, leaving us with a slope of 0. And the bottom side, the green line, once again, the y coordinates are the same, namely 0, so we get a slope of 0. So that tells us that those two lines are also parallel, guaranteeing that we have a parallelogram. The third thing we need to do is identify any other formulae you will need to use in this proof. Most people think about the distance formula, because when they think about the diagonals bisecting each other, they start thinking, well, geez, segment LH and segment NH have to be the same, so I can use the distance formula and show those coordinates are the same, and then I can show that KH is congruent to MH by using the distance formula. But how are you going to find the coordinates of H? That is the trick. You can't just simply choose random coordinates, because the coordinates have to be related to both the lines that point H lies on. So the distance formula might not be the best way to go. How about the midpoint formula? Think about this. The proof has asked us to show that segments bisect each other. So that's kind of an idea that we're going to be using midpoint. So we can use the midpoint formula, and that means that we need to adjust our coordinates. Once again, we times all the variables by 2, allowing us to use the midpoint formula. So notice, to prepare a proof, place the figure on the coordinate plane using the rules. Double check to make sure you have the correct figure by using the distance and slope formulae, and identify any other formulae you may need to use in the proof. From there, adjust coordinates as necessary.